Michael Faraday was one of history's greatest scientists, yet his name is barely known outside of science circles. He discovered the principles behind electric motors and generators, coined the term electrosynthesis, and laid the foundation for our understanding of electromagnetism. His work enabled the very technology that allows us to watch this video right now, so let's find out how he did it. Michael Faraday was born in 1791 to two poor parents who lived in a small village in England. In fact, he was born in a worker's cottage on the grounds of a manor house. Growing up, his family struggled financially, but his mother was determined that he would receive an education. She worked as a lowly servant in the house nearby, working long hours so that she could afford to send Michael to a boarding school run by a local pastor. When Michael was 14, he began working as an apprentice bookbinder, working long hours every day binding books by hand with little pay. Although his boss paid him very little, he recognized Michael's intelligence and bought him a compass, which started Michael's lifelong interest in science. Every night after work, Michael would read books from a circulating library, teaching himself about science and math. The only problem was that when his apprenticeship ended at age 21, he had no money and no job skills. He couldn't afford to go to university and didn't know any influential people who could help him get a job. So Faraday's scientific career nearly ended before it even began. But fortunately, his friend noticed an advertisement looking for an assistant to the famous scientist Humphrey Davy, who was the head of chemistry at the Royal Institute and a member of the Royal Society. Faraday wrote to him and asked for a position, but Davy never responded. So Faraday decided to take matters into his own hands. He walked barefoot to Davy's house and rang the doorbell. When Davy's maid answered, Faraday asked if he could just speak to Davy for 5 minutes. When she went to ask Davy, he responded, "Tell him I won't see him." But Faraday refused to leave, insisting that he needed to talk to Davy. Eventually, Davy agreed to meet with Faraday, and soon afterwards, Faraday became his assistant. At the time, electrolysis was a new technique that scientists were just beginning to experiment with. They had discovered that running an electric current through certain chemicals would cause them to decompose into their various elements. For example, if you pass a current through water, you can split it into hydrogen and oxygen. This process is still used today to produce hydrogen fuel, except instead of passing electricity through water, we pass electricity through a chemical called an electrolyte. The electricity breaks apart the molecules of the electrolyte, leaving behind hydrogen gas. We collect this hydrogen and then use it as fuel. When Faraday joined Davy's team, they were attempting to do the same thing with table salt. Passing electricity through a salt solution did break it down into its various components, but the results were different than expected. Not only were chemists getting hydrogen and oxygen, they were also getting a mysterious substance that looked like ice but wasn't quite ice, and nobody knew what it was. Davy thought it might be a new element, and he enlisted Faraday to investigate. Over the next few months, Faraday experimented with this mysterious substance and eventually realized that it was simply water. Somebody had accidentally contaminated the salt with water, and then the electrolysis decomposed the water into hydrogen and oxygen. While this may sound disappointing, it actually had huge implications for Faraday's future. You see, Davy was credited with discovering electrolysis, and although Faraday didn't discover anything new, his experiments gave him a much better understanding of electrochemistry, which would later allow him to discover the principle behind electric motors and generators. When Davy went on tour, he would often leave Faraday in charge of his lab. One time while Davy was away, Faraday was left alone in the lab overnight and he got bored. So he started playing around with some equipment. He attached a wire to each end of a battery and then dipped both wires into a glass of water. Much to his surprise, the water started boiling. He realized that running a current through water caused it to heat up. He also noticed that if he turned the current off, the temperature stopped rising. He repeated this experiment over and over again with other liquids, and found the same thing happened every time. Turning the current on heated the liquid, and turning the current off stopped the heating. He realized that there was some sort of relationship between electricity and magnetism, but he couldn't figure out what it was. At the time, scientists didn't even know what electricity and magnetism actually were. Nobody knew how they worked or how they were related to each other. Nobody even knew if they were related at all. Scientists believed that electricity and magnetism were produced by two completely separate forces, one force for electricity and another for magnetism. The truth is, though, that electricity and magnetism are actually two sides of the same coin. They are different manifestations of a single force called electromagnetism, and Faraday's accidental discovery of the relationship between electricity and magnetism opened up a whole new field of physics. Faraday didn't stop there either. He continued experimenting and discovered the principle of electromagnetic induction. To explain this phenomenon, let's imagine a metal ring sitting on top of a coil of wire. If we turn a current on inside the coil, it creates a magnetic field that extends outwards from the coil. The magnetic field lines go through the metal ring. Now, if we change the strength of the current, the magnetic field lines through the ring change. This causes electrons in the ring to move. Electrons moving through a closed circuit creates a current. So if you have a coil of wire and a metal ring sitting on top of it, changing the current through the coil will create a current in the ring. It's as simple as that. This may seem like a minor detail, but it has huge implications. Let's say we want to build a motor. A motor converts electrical energy into mechanical energy. That means it converts electricity into motion. All motors need a strong electromagnet and a way to change the direction of the magnetic field. Our changing magnetic field from earlier accomplishes exactly that. We can stack magnets on top of each other and place a wire in between each magnet. Changing the magnetic field from one magnet affects the electron flow in the wire. Since electrons are negatively charged, they will try to move away from each other. When the electrons in one wire pile up on one side, creating a positive charge, electrons from the neighboring wire will move towards it. This movement of electrons from one wire to the other creates a current in the overall circuit. As electrons move from the negative terminal of the battery through the first wire, they will push against the electrons in the wire trying to move towards the positive terminal of the battery. This causes a torque, which will rotate the shaft of the motor. By using multiple coils and switching the direction of the current through each coil, we can create a rotating magnetic field that spins the shaft continuously. The same thing happens with generators too. Generators convert mechanical energy into electrical energy. In other words, they convert motion into electricity. Faraday discovered the principle behind all modern generators by wrapping a wire around a pair of permanent magnets and spinning it around. As the wire spun past the magnets, a current flowed through it. Today, generators use electromagnets instead of permanent magnets, so that they can control the strength of the magnetic field, increasing or decreasing the voltage. Generators are what power almost everything around us. Whenever you flip a light switch or plug in an appliance, you're using electricity generated by Faraday's principle. Faraday continued making important discoveries until his death. He was knighted in 1835 and appointed to the Royal Society, where he continued his research until his death in 1867. Despite his many contributions to science, his work had mostly been forgotten by the general public. However, in 1962, the movie Faraday Cage helped revive his legacy, and today we have the Michael Faraday Prize awarded annually by the Institute of Physics to the best experimental physicist in the world. Now you know a little more about the amazing Michael Faraday. Thanks for watching till the end, and I'll see you in the next video.